I'm Andrew Trunick from the NASA Glenn Research Center. My co-authors are Robin Pertz and Jillian Zudell from Alcyon Technical Services. Transportation is evolving and will continue to evolve. We are pleased to present Melanin-inspired solutions for transformative transportation. Melanin is a general term used to refer to a broad class of functional biomacromolecules produced by living organisms throughout the entirety of the biosphere. Melanins have traditionally been thought of as strictly pigments, whose only function was to impart color. Imparting color could be the least of the many functions that melanins perform. Melanins have been found to possess a broad range of properties, unmatched by any other single material. These properties have the potential to enable new and innovative solutions for transportation applications. Melanins are ubiquitous throughout the biosphere and are present in organisms from the depths of the Marianas Trench, where the pressure is greater than 15,000 pounds per square inch, to the McMurdo dry valleys of Antarctica, which is as close to Mars as we can get on Earth, where rain hasn't fell for more than 2 million years. Melanin is present in all life forms, from bacteria to humans, and everywhere in between. Melanin can be produced synthetically by numerous methods. Synthesis allows tailoring of melanin's properties, enhancing one or more attributes, while suppressing others to fit specific applications. Synthesis also allows the process to be performed under well-controlled laboratory conditions. The synthetic approach allows for the introduction of new properties that are not present in melanin itself. A synthetic approach lends itself to the creation of melanized or melanin-modified materials like aerogels or metal ion-loaded melanin nanoparticles. Scopus is an expertly curated citation and abstract database. Our research was analytical in nature. Due to melanin's importance to human health, the majority of published research is medical in nature. The question became, how could we interrogate millions of records in the vast database of Scopus to show what non-medical melanin research has been done, then organize those results to get a better understanding where the research focus has been and identify gaps that remain unexplored. A manual approach was impossible. We opted for a natural language approach. To return data from Scopus that was relevant, search queries were built with a focus on non-medical melanin research, using terms and words of interest. Queries also contained exclusion terms, like religion, to prevent irrelevant information from being included. The data returned by the queries were uploaded to the QUID platform. QUID is a commercially available software product that relies on the use of natural language processing to scan, categorize, catalog, and build virtual networks of large amounts of interconnected data. The results were filtered and cleaned up to remove irrelevant results or results that had insufficient metadata to create a cluster. The results are displayed as a virtual network. These networks enable a large amount of data to be displayed and examined for patterns or trends that may exist, but are not visible or obvious using more traditional plots and graphs. Clusters are assigned colors and labels and built around nodes with similar terms. The network is dynamic. Clicking on any node in the network will display the detailed metadata for that node. QUID's capabilities enable the data to be pivoted on various output formats, including timelines, as shown here. Analysis of the data showed that the vast majority of the publications were relatively recent, within the last few decades. Prior to Chernobyl, non-medical melanin publications were minimal. The accidental discovery of highly melanized fungi thriving in the deadly radiation of Chernobyl seems to be the impetus that spurred an interest in melanin research. A seminal paper by Nelly Zadanova and others discussed the destruction of radioactive particles by fungi. followed soon after by Katerina Dodikova and Arturo Casadeval's paper on how fungi cope in a high radiation environment with the help of melanin. Since those two papers, non-medical melanin research has grown significantly and continues to grow. Melanin properties and application. Melanin's broad band absorption goes from the UV through the whole visible light spectrum. Melanin enables a whole new era of UV-stabilized polymers and UV absorbers. Melanin opens the door to new ways of achieving thermal regulation due to its high thermal conductivity, as reported by Kim. Melanin-based electronic materials research is literally exploding due to the possibility of bio-inspired and biocompatible electronics. Energy harvesting applications. The first law of thermodynamics states that energy can be neither created nor destroyed. Melanin obeys that law by energy transformation. Melanin has been shown to effectively transform radiation into other forms of kinetic and potential energy. Transportation, by definition, is energy transformation. Melanin-enhanced materials. Melanin has an affinity for metal ions. Transportation applications include enhancements to lithium-ion batteries in the form of anode and cathode technology, energy storage devices like supercapacitors and piezoelectric sensors. Antifungal additives can be used for keeping vehicles and infrastructure clean and safe by possibly inhibiting the growth of germs and bacteria. Space transportation. Wherever we go and by what method we get there remains to be seen, but melanin can help shield humans and vehicles from the harmful effects of radiation in space. Melanin research realistically has a little over 2 decades of serious activity. Most other well-developed technologies have closer to a century of development. Given melanin's broad spectrum of properties, the overwhelming majority of its potential and applications remains to be discovered. To put this into perspective, the majority of non-medical melanin research remains either in the basic research or proof of concept stage. It is reasonable to surmise that a global industry devoted to the advancement of melanin-based technology will evolve. Thank you for your time and attention, and this concludes our presentation.